Hello, welcome to the TES Secondary Maths Resource of the Week number 66 with me, Craig Barton. Now, if you've never played the game Dots and Boxes, you have never lived. And seeing as this resource is a mathematical twist on the classic pencil and paper game, I thought we'd best start with a very quick recap of how you actually play the game. And I've put a link to this wiki page in the blog post description. So traditionally the game is played on a board that's made up of a load of dots, and it's either a 2-player, 3-player, 4-player or whatever game, and players taken in turns to draw a line, either horizontal or vertical, connecting two dots together. And the idea is you want to create a closed-in square. So you want to be, if there's 3 sides of a square, you want to be the person who puts that 4th line in that completes the square, because every time you complete a square you get to capture that square, you get a point for it, and then you get another go. So the game progresses slowly and tactically at first, and there's an image of a completed game, and you can see that player A has got a few squares, player B's got a few squares. But what you tend to find is you get long chains, and then when you get towards the end of the game, somebody puts in one line, completes a square, does another, completes a square, and you get a big chain, and you end up cleaning up with loads of points. Now, I know what you're thinking here, why are you bothering telling me this, because that's absolutely nothing to do with maths. Well, as we've seen in the past, the imagination of the authors of TES Maths resources is absolutely ridiculous. We've seen Monopoly converted into maths, Pointless converted into maths, Cluedo converted into maths, so why not boxes? And what a wonderful spin on this we've got, because we've got not just any old boxes, but algebra boxes, created by one of my favourite TES Maths contributors. Now, it's a very simple resource. It is just one simple grid here, and it looks like that. Now, imagine that the intersections between the squares are your dots, and obviously you can put dots on there yourself. And every time you capture a square, you don't just get 1 point, but in fact you get a letter. And you can see where this is going to be going, because what we can do here is we can practice some collecting like terms. Because if I capture the 2z square, and I also at the same time capture the z square, then what have I got? Well, I've got 2z and I've got z, so I've got 3z. And of course that then lends itself nicely to the possibility of giving z an actual value, so in this case z is 3, so we can practice a bit of algebraic substitution as well. So we've got collecting simple like terms, and we've got simple algebraic substitution, all wrapped up in the wonderful game of dots and boxes. But as you know, on these videos, I like to try and look for ways to extend the resource. So why limit ourselves to simple collecting like terms? What's wrong with chucking in a little y squared here, or even something like an x take 3y for particular values of squares, so we get more complex collecting like terms and simplifying expressions? And then, of course, when we come to the substitution part, why limit ourselves to 1s, 2s, 3s and 4s? What about a -3? What about a 2.5? What about a 20? So let's bring a few more tactics into the algebraic boxes realm, just to get the children thinking a bit more and using a bit more mathematical challenge in there. So I absolutely love simple things like this that have a bit of competition in there, and that the only resources you need are the actual boxes board. But then we can really extend the children's thinking. And it got me thinking as well that I've got a year 8 class that's pretty, I mean, it's in theory it's setted, but it's pretty mixed ability within there, and it's often tricky to differentiate. But here's your perfect differentiation. Just get 5 or 6 variations of this board out and get the kids playing different boards. All the kids are doing the same task, they're all getting involved, all playing the same game of boxes, but just on different boards. And some of those boards could have squares on them and negatives on them, and some of them could have decimal values for the letters, and so on. So a wonderfully simple resource, an absolutely brilliant idea, and I think that's going to become an absolutely essential part of my collecting like terms and substitution for many years to come. So thanks so much for uploading that, and I'll be back with a fresh resource of the week next week. Take care, and bye for now.